So for this video, we'll be talking about the least common multiple. So first we start with defining what we mean by multiple. So a multiple is a number, say n. We say that n is a multiple of another number, say capital N, if n is equal to n8, with a in Z. So it's hard to comprehend by just simply with this formula. So let's try example. So we say, if capital N is 2, so its multiples are say the set containing 2, 4, 6, 8, 10, and so on. So why is that? Since 2 is equal to 2 times 1, 4 is equal to 2 times 2, 6 is equal to 2 times 3, 8 is equal to 2 times 4, and 10 is equal to 2 times 5. So it's like this one, this one is the A part out here. So these are the multiples of 2. Simply just like you keep on adding 2, or you're multiplying 2 to another integer. So just take note of this. Now let's start by showing some examples of we define the least common multiple as, by the name itself, it's the smallest multiple that is common between 2 or more numbers. Or should I say, if there are 3 or more numbers, we use among 3 or more numbers, not between. So let's try 2 and 3. We try to list the multiples of this one. Let's not use this equal symbol out here, since it's not equal. Let's just try this one. So the multiples of 2 are 2, 4, 6, 8, 10, 12, and so on. The multiples of 3 are 3, 6, 9, 12, 15, and so on. Now, as we can observe here, their common multiple first is 6 and 12. There are still many more common multiples between 2 and 3, but since we are only tasked to find the least one, we have 6 as the least common multiple of 3 and 2. Let's try more examples. So see if we have 6 and 9. The least common multiples of 6 are, the multiples of 6 are 6, 12, 18, 24, 30, 36, and so on. For 9, we have 9, 18, 27, 36, what else? 45, and so on. So again, their first common multiple is this one, 18, and we also have 36, and so on. Since we're tasked again only to find the least common multiple, we have 18 as the least common multiple of 6. So just a simple step. Now what if the given number or the given numbers are larger and it's more hard to list them all? Now we will present two methods in answering least common multiple questions that is probably harder to list down. So we start with the prime factorization method. So say if we have 10 and 15, we first list out its prime factors. By prime factorization, we know that we can decompose this as 2 and 5, and this one is 3 and 5. Now, since these are prime, let's circle it out. Take notes. Now, we know that we can represent 10 as 2 times 5. And we can represent we can represent 15 as 3 times 5. So, how do we obtain the LCM from this one? So what we do is we simply check its factors and check that between the two numbers, which of these factors has the higher exponent? Or let's just show it in an example. So first with 2. Now clearly 2 is an exponent of 1. Same with this one. It's an exponent of 1, 1, and 1. The question is, if we compare 2 as a factor of 10 and 2 as a factor of 15, which is the higher exponent? Clearly, it is this one, since 15 does not have a factor of 2. Or you can explicitly show it as this one. 15, although it does not have a factor of 2, we can write 2 as 2 raised to 0. So now if we compare, the 2 here has the higher exponent. So that would be our first factor for LCM later on. How about 3? Now we can do the same process. So this out here, we can multiply 3 raised to 0 out here. So that clearly we know that this is the factor that take 3 raised to 1. How about for this one? Since they are the same, 5 raised to 1 and 5 raised to 1, simply take any of them. So we take this one. So now, we can write the LCM of 10 and 15 as 2 times 3 times 5, which will give us 30. Yep. So, the thing to note here in using prime factorization is that in taking the factors for the LCM, what we take is the one with the higher exponent. So say if we have a number a and b, and this one has a factor of x raised to 10, and this one has a factor of x raised to 5. So what we take in our LCM is this one, since it has the higher exponent. So see if it has another factor, let's say y, this one is y raised to 2, and such. So we take this one since this one only has a factor. So the LCM of this one would become, let's write that as LCM of a and b, would become x raised to 10 y squared. Like that. So now we go on to our last method that we will use for this video, and that is the continuous division method. For this time, let's try 3 numbers. So say if we have 6, 18, and 45. First, applying continuous division, we know that a clear factor among these 3 is 3. Yep. So, applying continuous division, that would give us 2, 6, and 15. Now observe here that the common factor for all of these 3 is only 1. So, do we simply just write, or do we simply just end here? But the answer is no, since if you compare by 2's, this 2 has a common factor. This 2 as well has a common factor. So what we do is we keep repeating, we continue the process, but only for the 2 numbers. We say if we have 2 here, since 2 is a common factor of 2 and 6, So we have 1, and this would have 3. What do we do with 15? What we do is we simply bring it down. So we have 15. Now next is, for this one, since 1 and 3 doesn't have any common factors, but 3 and 15 has a common factor, we do that process again. We write 3 out here, and we arrive to 1, 1, and 5. Now, this is already the bottom, since if we try to compare even by 2's, their common factor will only be 1 only. So that is the end for this. So take note of that one, since in our previous continuous division examples, for example, for one number, our final outcome would still be a prime, say 2 or probably 3 or whatever. So for this one, our bottom part must contain 1 oftentimes, but there's still cases that the bottom can only consist of primes. So say if you have 2, 3, and 5, all of this doesn't have any common factors anymore. But oftentimes, the last part would contain 1. So take note of that one. So how do we obtain the LCM from this one? What we do is we multiply this part by this part, the left column and the bottom part. So let's do that. But first, let's move this out here. So now we can represent the LCM of 6, 18, and 45 as 3 times 2 times 3 times 1 times 1 times 5, or 2 times 3 squared times 5. 2 times 5 is 10, so we can write it as 10. 3 squared is 9, so 10 times 9 should give us 90. So we have presented 3 methods out here. First is the basic method, the listing method. Next is the factor tree method. And the third is the continuous division method. So we'll provide more examples in probably the following video, or probably in some couple of next videos. So that's all for this video.